guys, welcome to Maths Up channel. This is Michael Matix. Today we'll be looking at the topic which says solving linear inequalities. Solving inequalities. First, we're going to look at the question which says 5x plus 1 is greater than 16. So in any case, how do we solve this particular question? I'm going to start by collecting like terms. When you collect like terms, you get 5x equal to 16 minus 1. In this case, I am moving positive 1 across the equal sign to give us 16 minus 1. When 16, you take away 1 from 16, you get 15. So we'll have 5x equal to 16. And how do we find the value of x? We divide both sides by 5. So 5x divided by 5, 5 cancels 5, we have x remaining, and 15 divided by 5 gives us 3. In the same way, we solve the equation. We also have to solve the inequalities. But one thing that is different here is the symbol sign, because the difference between inequality and equation is just equation, the equal sign. The equal sign. So 5x is greater than 15. I have moved positive 1 across the symbol greater than to give me 16 minus 1. In that case, it's giving me now 5x greater than 15. If I simplify further, meaning dividing both sides by 5, exactly what we did on the right hand side when we're solving the equation, we're going to get x is greater than 3, meaning that x is bigger than 3. All the values or possible values of x will be bigger than 3. So what do? Where we'll have the positive 3 on the number line, you see I'm going to draw an arrow going towards the right to show all the possible values of x. If it says x is bigger than 3, so 3 is not included in our solution. Therefore, our solution is 4, 5, 6, 7, 8, 9, 10, and so on and so forth. So this is how to solve a linear inequality. We're going to take another question on this which says 5 minus x greater than 12. So how do we solve this? We are going to collect like terms. If I collect like terms, exactly what you have on the right hand side, solving equation, we are going to do same here. I am moving positive 5 across the symbol to give me 12 minus 5. On the left hand side, I'm left with minus x. But don't forget, the coefficient of this is 1. So it's just like you have minus 1x greater than 12 minus 5. Let's go on. Now, if you take away 5 from 12, you're going to get 7. So minus x greater than 7. What happens next? If I divide both sides by minus 1, which is the coefficient of x, so I'm going to get on the left hand side x, and on the right hand side I will have minus 7, because 7 divided by minus 1 is minus 7. But what happened then? You see that the symbol flipped, it turned to the other side. So don't forget, whenever you divide or multiply with a negative coefficient, the symbol changes. Whenever you divide or multiply with a negative coefficient, it changes. Now, how do we represent this onto a number line? When x is less than minus 7, so x is any number that is less than minus 7. So where I have minus 7 on my number line, I'm going to draw a circle, and you can see from here that all the numbers that satisfy the value of x could be minus 8, minus 9, minus 10, and so on and so forth. 7 is not included in our solution. Let's take another question. Here, 3 plus 2x greater than or equal to 10. We're going to collect like terms. If I move positive 3 across the symbol to give me 2x greater than or equal to 10 minus 3. If you take away 3 from 10, it will give you 7. We are left with 2x greater than or equal to 7. Now I'm going to divide both sides by 2. So 2x divided by 2 leaves me with x, and 7 divided by 2 will give me 3.5, which is 3.5. So my solution is x is greater than or equal to 3.5. Now coming to putting this onto a number line, on my number line where you have x 3.5, you see it's in between 3 and 4. And why is this circle shaded whenever it is greater than or equal to or less than or equal to? This circle is closed. Now let's see what are the possible values of x. It could be 3.5, it could be 4, 5, 6, 7, 8, and so on and so forth. Let's look at the last question for this episode. The question says 7 minus 2x greater than or equal to 13. I'm going to collect like terms by moving 7 across the other side. I'll be left with minus 2x greater than or equal to 13 minus 7. Sorry. If you do that operation there, 13 minus 7, you are left with 6 on the right hand side, and on the left hand side you are left with 2 minus 2x greater than or equal to 6. So let's see. I'm going to divide both sides by 2. If you divide minus 2x divided by 2, you get x. And 6 divided by minus 2, it will give us minus 3. But don't forget, whenever you divide or multiply with a negative coefficient, any negative number, the symbol flips. So what happens here, from the beginning it was 2x minus 2x greater than or equal to 6. But on our last final answer, it's showing that x is less than or equal to minus 3. So how do we represent this onto a number line? Where we have minus 3, you're going to draw a circle, and the circle has to be closed, shaded, and draw an arrow towards the left side. So all the possible values of x could be minus 3, minus 4, minus 5, and so on and so forth.